And in today's episode, among other things, you'll see Elon Musk announced TerraFab and it will be focused on building AI in space. Meanwhile, Astroport introduced a machine that will build habitats on the moon. We'll also see that Guardian's new drone is combining Starlink, robotic battery swapping, and pursuit response at 96 kilometers per hour. And last but not least, Tesla announced the Optimus GEN3, which they say is incredibly similar to a human being. All this is happening amid a wave of engineer hiring that the company is doing. Let's understand all this and some other technologies as well. Hello, impressed viewers. I'm Realidade Impressionante, and you're watching Realidade Impressionante. And there's a limit that not everyone notices. And it's not in the technology, it's in the energy. Because the biggest obstacle for artificial intelligence to grow even more isn't the software or the algorithms. It's the ability to generate computational power at scale. And whether you like it or not, Elon Musk seems to have taken this seriously before his competitors. In a new announcement, he revealed TerraFab, a project that could completely redefine the way the world is producing its chips. The idea is actually pretty simple to understand. It's to unite Tesla, SPACEX, and XAI to build the largest semiconductor factory on the planet. All of this in a single place, with a goal that's almost unbelievable: to generate 1 terawatt of computing capacity per year. Just so you have an idea, that's equivalent to 1 million megawatts of scale, far beyond what the current industry can deliver. But what really draws attention? It's not even all of that. It's how Musk plans to carry out this endeavor. As always, he's not just thinking about Earth. Part of his plan involves taking computing to space. His idea is to create data centers in orbit powered by solar energy, which is practically unlimited. That's because outside the planet, there is no night, and the energy out there can be more constant, cheaper, and more abundant. And that completely changes the equation. To make this idea feasible, Musk proposed 2 types of chips. The first one is aimed here at Earth. One to power autonomous cars and Optimus humanoid robots. A machine that, according to him, could be produced on a much larger scale than the cars themselves. The second one was designed specifically for space. A chip designed to operate in artificial intelligence satellites, forming a distributed computing network outside the planet. Each unit would be generating energy, processing data, and expanding the artificial intelligence's capacity without relying on ground infrastructure. This raises a possibility that until recently seemed like just science fiction. Intelligence. Artificial intelligence no longer being limited to our planet and starting to exist on an orbital scale. He even suggested something even more ambitious. In the future, this structure could expand to the moon, thus creating an industrial base that would be able to operate at energy levels thousands of times greater than what we have today. And I know saying it like this might sound far-fetched, but there's a very important point here. All great revolutions start this way, with an idea that seems impossible at first, but generating computational power at scale is only part of the equation, because above all, we need to get to space faster. So pay attention to this next segment here, and you'll understand it's closely related. If the race for artificial intelligence is leaving Earth, then there's an immediate problem. How can we quickly and efficiently build the infrastructure that's needed to get there? Because rockets aren't simple to make. It might seem like they are, but they're not. It's actually the opposite. They're some of the most complex machines ever created by humanity. Each engine is made up of dozens, sometimes hundreds of different parts. They're made from different materials, designed to withstand extreme temperatures, absurd pressure, and also conditions that are almost impossible to reproduce in a laboratory. And the biggest problem is that all of this takes time. A lot of time. Each part needs to be manufactured separately, tested, and then assembled in a process that involves welding, fitting, and multiple steps. A system that is expensive, slow, and full. But now, researchers have developed a solution that really can completely change this scenario. A new type of 3D printing capable of manufacturing rocket components using multiple metals at the same time. Instead of producing each step separately, this technology allows entire structures to be created all at once. And that's with different materials being placed exactly where they're needed. Stronger heat-resistant metals in critical areas, lighter materials where weight matters, and even magnetic combinations for internal system control. All of this in a single print. And the impact of that is huge because besides drastically reducing the number of parts, it also speeds up development. What used to take weeks can now be adjusted directly on the computer and redone almost instantly when this technology is 100% ready. Building rockets faster is just the start, my friends. Once we're on other worlds, the challenge is entirely different. Pay attention and you'll see. We still don't know if or when our species will start living permanently on a lunar base, mainly due to the extreme challenges and even the current delays in the Artemis mission, for example. Because of course, it's not enough to just land on the moon, we need to build a base there. And that's why a new approach is emerging. Before sending humans to stay there, they're planning to send machines. Astroport has developed a system that could become the foundation of lunar construction. It's a kind of automated excavator designed to operate directly on the surface of the moon. But it doesn't work alone. This machine is part of a system that is modular, attached to the robotic vehicle and capable of carrying different tools. It's like a fully automated construction site, but outside of Earth. During recent tests, this technology has already demonstrated the ability to move large amounts of simulated lunar soil in just a few minutes. But the goal goes far beyond that. These machines will be responsible for preparing the terrain even before the astronauts' future longer stay. When the time comes, they will be building roads, platforms, landing pads, and safe areas for future constructions. And there's a detail that's impressive about all of this. Lunar dust can be transformed. Using extreme heat, it can be melted and converted into solid surfaces. Basically, the moon's own soil can be used as a building material. This means that instead of bringing everything from Earth, which is very costly, the infrastructure can be created directly in the lunar environment. And this completely changes the logic of space exploration. Because for the first time, we're not just planning to visit. We are now preparing to stay there. And that requires scale. These machines will need to move thousands of tons of material in order to create a functional base. And more than that, to pave the way for something even bigger. An economy beyond Earth with mining, infrastructure, and even the extraction of rare resources, like helium-3, for example, which is considered by many to be the new possible key to the energy of the future. Okay, I know, it might seem like something really far off, given the recent news we've been seeing out there. But the reality is that all of this has already started to be prepared. The fact is that while some technologies are being prepared to operate outside of Earth, others are already changing what happens down here. And that's happening in real time. Let's take a look so we can understand. There's a problem that few people who haven't been through this situation realize. In emergencies, time is everything. And often the first few minutes are the most decisive. With that in mind, the startup Brink developed a drone that's capable of responding to emergency calls even before human teams arrive at the scene. As soon as the emergency call is made, the system can automatically identify critical situations and send the drone almost instantly. No waiting, no traffic, and no delay. And that matters because this drone isn't just fast. It's smart. It can carry specific equipment for each type of incident: defibrillators, rescue devices, or even emergency medications. All of this is prepared even before takeoff. And there's more. Unlike conventional drones, this system was designed to operate without interruptions. It lands on an automated base, swaps its own battery, and gets back in the air in just a few minutes. In other words, it operates practically 24 hours a day. But perhaps the most impressive detail is the collectivity. This drone uses satellite communication, which means it keeps working even in places without cellular network signal or in areas affected by disasters. In practice, it can be sent anywhere on the planet at any time. And with its advanced sensors, it can see at a distance, in the dark, and in adverse conditions. It works like an eye in the sky that can get there first, assess the situation, and even guide people on the ground. And that's cool because it happens even before human teams arrive. But thinking outside the box raises an inevitable question. When a machine starts to arrive before us humans in an emergency, is it still just a tool? Or is it already part of the decision-making done by machines? And more than that, how far can all this technology go? Tesla is accelerating the development of its humanoid robot, Optimus. And according to Elon Musk, it could become the greatest product ever created. Not just in technological impact, but in scale. The company is now in a critical phase, leaving behind the prototypes and entering the most difficult territory of all, mass production. And this can already be seen quite clearly. Tesla has started a new global recruitment campaign looking for engineers, artificial intelligence specialists, and high-level professionals in various areas related to what they are doing. This clearly shows the project is no longer just experimental, but fully industrial. But what has really caught everyone's attention is the new direction they are now taking and giving to this robot. The next generation of Optimus is being developed with a very specific goal. to get closer and closer to the human form. According to the engineers involved in the project, the robot may reach a point where it won't even look like a machine anymore, but rather a human being with some kind of technological suit. This isn't just about looks, it's about function. The new hand system, for example, is being designed to have dozens of actuators, thus allowing extremely precise movements, capable of handling delicate objects. Inside the laboratories, for example, the robots are already learning things like doing laundry. Yeah, it's something simple for us humans, but for machines it's extremely complex. That's because it involves dealing with objects that constantly change shape. And to teach all this to a robot, there's another challenge that's even bigger. Data. Lots of data. Tesla is investing heavily in simulations, reinforcement learning, and massive data collection. Because in the end, the bottleneck is no longer the hardware, but rather teaching the machines to understand our world. And that explains the urgency with which they have been handling all of this. The company is racing against time and against the competition. Other companies are quickly advancing, competing for talent, and aiming to be first in this new market, which Musk says will be worth trillions. Because if a robot really reaches mass production on a large scale, the impact will be gigantic for all of us. It will be a new workforce capable of performing physical tasks with great precision, at scale, and with availability that is continuous, practically 24 hours a day. And this completely changes the rules of the economy. Because for the first time in history, we're not just automating machines. We're now automating human labor itself. But building a robot is one thing, making it work like a human being is something completely different, isn't it? There's a part of the human body that seems simple but is extremely complex. It's our hand, because it's not just about strength. It's about precision, sensitivity, and real-time adaptation. And now, Xiaomi may have taken a decisive step to solve this. They introduced a new version of the hand for their humanoid robot. And the goal is clear, to get as close as possible to human capability. And the first step was physical. The new hand was redesigned to be almost the same size as a real human hand, a 1-to-1 ratio. But what's really impressive is what's inside it. The system now has dozens of degrees of freedom, allowing the movements to be extremely complex. Now, the robotic hand is able to replicate the way human fingers move. But movement alone doesn't solve much, does it? Because a hand without sensitivity is practically useless when it comes to our tasks. And that's why the company invested heavily in tactile sensors. The new version can capture information across the entire surface of the hand, including the fingers, palm, and critical contact points. It's as if the robot, in quotes, could feel. And to teach them this, they used special gloves. The human operators wear these gloves and every movement is captured with great precision. This turns real actions into data the robot can learn from. But there's an even bigger problem. Inside this hand, there are extremely powerful motors. And when they work for a long time, they generate an absurd amount of thermal energy, enough to compromise the entire system. And that's when a surprising solution came up. It was directly inspired by the human body itself. Xiaomi created a cooling system that works like sweat glands. These internal channels constantly release heat as if the device is sweating. This allows the robot to maintain consistent performance even under heavy use. And when you start to think and reason logically, and put together everything that's happening, robots being produced at scale, learning human tasks, and now gaining hands with precision and durability close to ours, it becomes clear that we are reaching a critical point, where machines stop being limited and start, even if still in a very rudimentary way, to interact with the physical world more and more naturally. And when these machines start to reach this level of precision, an inevitable question arises, my friends. Do they really need to look like us? Identical to us? When we think about intelligence, maybe what comes to mind is the head, right? That's where our human brain is. Well, at least some people have one. It's the center of everything. But for machines, that logic doesn't need to exist. And a new robot is proving exactly that. Researchers have unveiled a humanoid robot sent to Ukraine, featuring a completely new architecture. In this case, the head is not the control center. It only works as a set of sensors. The real, quote-unquote, brain of the machine is in the chest. That's already a tip for you if you ever need to face a machine like that, okay? The brain is in the chest. And that might seem really strange at first, I know. But there's a very simple reason for that. In the human body, nerve signals are relatively slow. They travel at about 120 meters per second. That's why it makes sense for the brain to be close to the main senses. It's to reduce response time. But in a robot, electronic signals move almost at the speed of light, which means that limitation simply doesn't exist for them. And that allows for total design freedom. The head can be dedicated only to perception, while processing is centered somewhere else. And this choice brings a very important advantage. The main structure of the robot can house a much more robust computational system, with better performance and greater heat dissipation capacity. And meanwhile, the head becomes a specialized module, equipped with motion sensors, cameras, and systems responsible for guiding the machine in space. And here's where an interesting detail comes in. Even with all this technological freedom, engineers are still inspired by biology. The head remains positioned at the highest point of the body, thus following an evolutionary principle known as cephalization. In other words, concentrating the sensors at one end to improve perception of the environment. With multiple cameras, the robot can nearly see its entire surroundings, staying constantly aware of everything happening. But perhaps the most intriguing point lies in the philosophy behind all of this. This robot is not trying to copy the human body. It is reinterpreting our body, keeping what makes sense and discarding what is not necessary. And this could be a clear sign of where robotics is heading. Less imitation and more efficiency. Because when machines stop copying us and start reinventing themselves, they stop being just printed versions of human beings and become something completely new. If you like this episode, please like and subscribe. Thanks for watching. See you next time. Just click one of the 2 suggestions on your screen. All right? Thank you so much, really. Bye. See you next time. Just click. It's quick. See you there.